Hey guys, in this video I will explain every subtopics in matrices and determinant in the form of problem solving. So the first problem is let A is a 2 by 3 matrix and B is a 3 by 2 matrix, as you can see here, such that A plus 2 times the transpose of the matrix B is a 0 matrix with the same dimension. Then which of the following is the value of Y? So A is given, B is given, but we need to know B transpose. We take the transpose of the matrix B first. So the transpose of a matrix will be obtained by interchanging rows into column. So change the first row of matrix B into first column, the second row into second column, the third row 1 minus x 2. This is B transpose. So 2 times B transpose means multiplying every entries of the transpose of matrix B. So this is 2, 0, 2 minus 2x minus 2y, 6, 4. You multiply every entries by 2, okay? This all will be multiplied by 2. So this is 2b. Now let's add A plus 2 times the transpose of the matrix is equals to 0, implies our matrix A is minus 2, 0, x, 2y, x plus y minus 4. We add this with twice of the transpose of the matrix B, which is 2, 0, 2 minus 2x minus 2y, 6, 4 is equals to 0, but this 0 is a 0 matrix with dimension 2 by 3. This is 0. Now let us add these two things. Let us add them. So adding these two, minus 2 will be added with 2. The result will be 0. Then 0 will be added with 0. Still the result is 0. X, this x will be added with 2 minus 2x, so the result is 2 minus x. Again add plus 2y with minus 2y, here it becomes 0. Add x plus y with 6, x plus y plus 6 plus 6, and minus 4 with 4, it becomes 0. This is the same as the 0 matrix with dimension 2 by 3. So these two matrices are the same, means 2 minus x must be 0, 2 minus x must be 0, and this x plus y plus 6 must be 0, x plus y plus 6 must be 0. So from here x will be 2, x will be 2, and use x in place of here. Use x is equals to 2, 2 plus y plus 6 is equals to 0. So this means y plus 8 is equals to 0. The y value becomes minus 8. So the answer for this problem is C. Let A and B be a 3 by 3 matrices. Here A is already given and we don't know the matrix B, but the determinant of the matrix B is 1 over 10. Which one of the following is equal to the determinant of 2 times the matrix A times the transpose of the matrix B? So here we will apply the properties of determinant. So to remind you some of the properties of the determinant, for any matrix A, a square matrix A, determinant of A and determinant of its transpose are the same. Similarly, you can say that determinant of matrix B and determinant of its transpose are the same. Okay, this is the properties of determinant of a matrix. So we will apply this thing. The other thing is we know that the determinant of K times a matrix, a square matrix A with 3 by 3 is K the power of 3 times determinant of the matrix A, where K is a certain real number, where K is a constant. So we will apply these properties to determine the problem. So the question, this symbol, the absolute value symbol, is the symbol for determinant here in our case. A times the determinant of 2 times A times B transpose is equals to the determinant of 2 times A times the determinant of B transpose. Okay, here we need to know some fact. Determinant of the product of 2 matrix is the same as determinant of A times determinant of B. This is also another property of determinant. So this is the same as 2 to the power of, this is the same as 2 to the power of 3, 2 to the power of 3 times determinant of A times determinant of B transpose. But determinant of B transpose and determinant of B are the same. So the result becomes 2 to the power of 3 times determinant of A times determinant of B. So this is 8 times determinant of A times determinant of B is already, it's given 1 over 10. So this becomes 8 over 10 times determinant of A. Now determinant of A can be obtained from the matrix A itself. The given matrix is a lower triangular matrix. So the determinant of this lower triangular matrix will be the product of the diagonal elements. So you can multiply the diagonal elements 2 with 5 and 1 over 2. Multiply all these 3 things. The determinant of the matrix A is 2 times 5 times 1 over 2, which is 5 itself. Therefore, here we will use 5. So 8 over 10 times 5, this is 40 over 10. The result is 4. Therefore, the answer for this question, for the determinant of 2 times A times B transpose, is B. So the answer is B. If a product of 2 matrix is given here, if this matrix is given and the determinant of the coefficient matrix is -5, then what is the value of X? This matrix, this product of matrix, is another version of the system of linear equation. So we have a certain system of linear equation, which is alpha x plus 2y plus beta z is equals to -5. And the second equation is 2x plus y plus 3z is equals to 5. The third equation is -x plus 0y plus z is equals to 0. This is a system of linear equation. So this system of linear equation is given in the form of matrix here in this problem. Okay, the given matrix is equivalent to this system of linear equation. Now, in this question, the determinant of the coefficient matrix is -5. So the coefficient matrix is -5, means the determinant of the coefficient matrix is alpha 2 beta 2 1 3 minus 1, 0, 1. The determinant of this matrix is minus 5. It is given here. So from this we will get alpha and beta. So let us evaluate the determinant of this matrix. So it is alpha into 1, 3, 0, 1 minus 2 times 2, 3 minus 1, 1 plus beta into 2, 1 minus 1, 0. Here you need to apply the principle to calculate the determinant of a certain matrix. So this value is minus 5, okay? So let us calculate each of them separately. So this means alpha into 1 times 1 is 1, 1 minus 0 is 0, minus 2 times 2 minus of minus 3, minus of minus 3, plus beta into 0 minus of minus 1 is minus 5. So rearranging this, it becomes alpha minus, this is plus 5 times minus 2 is minus 10, plus beta is equals to minus 5. This means alpha plus beta is 5. Taking this minus 10 to the right, alpha plus beta is 5. So let us keep this thing as it is. We will apply somewhere. So the other thing is from the third equation, we can take minus x plus 0y is 0 plus z is equals to 0. So this implies x is equals to z. X and z are the same. So I will use these values in the first and in the second equation. So in place of z, substitute x in the system of equation. So rewriting this system of equation, alpha x plus 2y plus beta z means beta x, because x and z are the same, is equals to minus 5. And the second equation becomes 2x plus y plus 3z means 3x, because x and z are the same. So this is 5. This is 5. So we can rewrite this system into like this: alpha plus beta times x, this x is common here, plus 2y is equals to minus 5, and here 2x with 3x, it's 5x, 5x plus y is equals to 5. Now in place of alpha plus beta, you can use 5. So this system becomes 5x plus 2y is equals to minus 5, and 5x plus y is 5. Now this is simultaneous equation of two variables. We can eliminate y by multiplying the second equation by minus 2 and the first equation by 2. Then this becomes 5x plus 2y is equals to minus 5, and minus 10x minus 2y is equals to minus 10. So adding downward, it becomes minus 5x is equals to y will be eliminated. Then it's minus 15. Minus 5 with minus 10 is minus 15. Dividing both sides by minus 5. X becomes negative 15 over negative 5, which is x is equals to positive 3. X becomes positive 3. So this is the required value of x. So our answer will be A. What is the solution set of the following system system of equation. This system of equation is given. We are asked the solution set of the given system of equation. Here, if we see the equations separately, we can observe that the third equation is a multiple of the first equation. Okay, if you multiply the first equation by -2, you will automatically obtain the third equation. So in this case, we don't expect the system of equation to have a unique solution. So this system of equation will have infinitely many solutions. Okay, the system will have infinitely many solutions. Always, it's good to observe the equations before proceeding to the solution process. So if you observe this kind of things, if there is one equation which is a multiple of the other, expect the solution to have infinitely many solutions. So let's see what it looks like. Simply add all the equations. Let us add all the equations. The equations are x plus y plus 2z is equals to 1, x plus 2y plus z is equals to 2, and minus 2x minus 2y minus, this is minus 2y, this is minus 2, so minus 2y minus 4z is equals to minus 2. If we simply add all the equations, x will be eliminated. Y plus 2y is 3y, 3y minus 2y is y, and 2z plus z is 3z, 3z minus 4z is minus z, is equals to, add this thing, 0, the only thing that will remain is 1. So y minus z is equals to 1. This implies y becomes z plus 1. Okay, since this equation, this system of equations have infinitely many solutions, we can fix some value for z. Say z is a certain constant number k, where k is an element of real number. Okay, if you fix z by a certain constant k, then y becomes z plus 1, that means k plus 1. So now you can use the first equation. Okay, use the first equation, x plus y plus 2z is equals to 1. So x plus y means k plus 1, and z means k is equals to 1. So this means x plus k plus 2k is 3k, plus 1 is equals to 0. This, I mean, is not is equals to 0, is equals to 1. Okay, this is 1. So this becomes x plus 3k is equals to 0. Therefore, x becomes minus 3k. So the solution set for this system becomes in the triplets x, y, z, where x is minus 3k, y is k plus 1, and z is fixed by k. So this is the solution where k is an element of real number. So the answer for this problem will be C. Suppose A is a 2 by 2 matrix here. If X is 2 by 2 matrix such that AX minus A transpose is 2 times A, then what is the value of X? It's not the value, the question is the matrix X. So let's see how we can find this unknown 2 by 2 matrix X. Given that matrix A is this, matrix A is 1, 2, 2, 3, and a certain unknown 2 by 2 matrix. Let us denote this unknown 2 by 2 matrix with entries A, B, C, D, satisfying the condition AX minus A transpose is equals to 2 times the matrix A. We want to find such a 2 by 2 matrix satisfying this condition. So let us write this thing as it is. A times X means A is 1, 2, 2, 3 times X is A, B, C, D minus A transpose. A transpose is 1, 2, 2, 3 is equals to 2 times matrix A. 1, 2, 2, 3. Okay, so this means 2, 4, 4, 6. So here we will apply the product of a matrix here. Okay, so when we find the product, we multiply this row by a column. So let us proceed. So multiplying this matrix, 1 times A is A plus 2 times C is 2C. Okay, now again multiply this row by the second column, so it becomes B plus 2D. Okay, now we have finished the first row. Go to the second row by the first column, so it becomes 2A plus 3C, 2A plus 3C, and multiply the second row by the second column, then it becomes 2B plus 3D. Okay, this is the product. Minus 1, 2, 2, 3 is equals to 2, 4, 4, 6. Okay, so you can take this matrix to the right side and add it. So the left hand side matrix becomes A plus 2C, B plus 2D. The second row is 2A plus 3C, 2B plus 3D is equals to adding these two matrices, this one and this one, you will get 3, 6, 6, 9. So from equality of the matrix, we will have this thing, to A plus 2C must be 3. A plus 2C is 3. Again, 2A plus 3C is 6. 2A plus 3C is 6. This is simultaneous equation of two variables. Again, we do have another simultaneous equation. B plus 2D is 6. B plus 2D is 6. Again, 2B plus 3D is 9. This is also from equality of matrix. So now we are left with a very simple concept, simultaneous equation of two variables. So here, multiply here the first equation by minus 2, the second one by 1, then you will get minus 2A minus 4C is equals to minus 6, and 2A plus 3C is equals to 6. So this becomes A will be eliminated, minus C is equals to 0. This implies C becomes 0. If C is 0, use the first or the second equation. If C is 0, A plus 2C is 3 means A will be 3. Okay, C is 0, A is 3. This is something that we get from the first system. Again, let's take this system of equation and use elimination to get the values of B and D. So take this equation as B plus 2D is equals to 6. 2B plus 3D is minus 9. So multiply the first equation by minus 2, the second one by 1. Then B will be eliminated. So it becomes minus 4D plus 3D is minus D. Minus D is equals to minus 12 plus 9. This means minus D is equals to minus 3. So D becomes positive 3. If D is positive 3, you can use the first equation. You can use this one. B plus 2D is equals to 6. This is 6. So B plus 6 is equals to 6 means B is 0. Now we can completely determine the matrix X. A is 3, B is 0, C is 0, D is 3. Okay, B is 0, D is 3, A is 3, C is 0. So we use these A, B, C, D values. So the matrix X is this one. So our answer will be D. Suppose that A and B are 3 by 3 matrices. I is identity matrix of order 3 such that the product of A and B is 2 times the identity matrix. The other information is if the determinant of the matrix B is 6, what is the determinant of A transpose? So we have all this information and we are asked the determinant of A transpose. So we know that the determinant of A transpose and the determinant of A are the same. So if we get the determinant of A, we have the determinant of A transpose. So let us use the information. A times B is the product of the matrix A and B is 2 times I. Now we can take both sides by the determinant. Taking by the determinant, we have determinant of A times B is the same as determinant of 2 times the identity matrix. Here we will apply the properties of determinant. So the product of determinant of the determinant of A and B is the same as determinant of A times determinant of B. Okay, this is the same as 2 the power of 3 times determinant of an identity matrix. Here we applied the properties of determinant on both sides. Okay, so use 6 in place of determinant of the matrix B. 6 times determinant of the matrix A is equals to 8 times determinant of any identity matrix is 1. 8 times 1. So dividing both sides by 6, the determinant of A is 8 over 6, which is simplified to 4 over 3. Therefore, since the determinant of A and A transpose are the same, therefore the determinant of A transpose is 4 over 3, which is the same as the determinant of A. So this is the required answer. Our answer will be B. If A is given by this matrix and A inverse is given by this one, what are the values of X and Y? Here we will apply the concept that says the product of any matrix with its inverse gives an identity matrix of the same size. So this is always true. A times A inverse in any order, it gives an identity matrix of the same size. So let us apply this thing. A is 0x 0, 1 minus 1 1, 0 y minus 1. This is matrix A, and its inverse is 1 1 1, 3 0 0, 2 0 minus 1. This must give us an identity matrix of 3 by 3. 1 0 0, 0 1 0, 0 0 1. This is an identity matrix for 3 by 3. So let us multiply this matrix A with its inverse. Multiplying 0 with 1 is 0, plus x with 3 is 3x, and 0 with 2 is 0. This is the first entry. Again, let us multiply the first row by the second column to get the second entry on the first row. So 0 times 1 is 0, plus x times 0 is 0, plus 0 times 0 is 0. Again, let's calculate the first row by the third column to get the third entry. So it becomes 0 times 1 is 0, x times 0 is 0, 0 times minus 1 is 0. Okay, we have finished the first row. Now let's calculate the second row. 1 times 1 is 1, minus 1 times 3 is minus 3, plus 1 times 2 is plus 2. Again, 1 times 1 minus 0 plus 0. The third entry on the second row is 1 times 1 is 1, minus 0 plus 1. Now plus 1, it's minus 1. So we have finished the second row. Let's go for the third row. 0 times 1 is 0, plus 3y minus 2. And the second element is 0 plus 0 plus 0. And lastly, we will have 0 plus 0 plus 1. This must be the same as the identity matrix. Okay, so now we can compare these two matrices. 3x must be 1. Okay, by comparison, 3x must be 1. And 3y minus 2 must be 0. 3y minus 2 must be 0. So 3x is equals to 1 means dividing both sides by 3. X becomes 1 over 3. X becomes 1 over 3. And 3y minus here, 3y minus 2 is equals to 0 means 3y is equals to 2. Dividing both sides by 3. Y becomes 2 over 3. Y becomes 2 over 3. So the question is the value of x and y, which is 1 over 3 and 2 over 3. So x is 1 over 3, y is 2 over 3. Therefore, our answer will be D. If A is a certain 3 by 3 matrix, then what is the determinant of A transpose times A? So here the question is the determinant of A transpose times A, which is the same as the determinant of A times the determinant of A transpose. Okay, from the property of the determinant of A and the determinant of A transpose are the same. So we can write like this. This is equivalent to determinant of A times determinant of A. So the required thing is the squared value of the determinant of A. We will calculate the determinant of A first, then we will square it. That will be the required value. So obviously the matrix A is a given, which is 3 minus 2 8 0 6 7 0 4 5. So it's very simple to obtain this determinant. The determinant of this matrix is calculated as 3 times 6 7 4 5 minus 0 times a certain 2 by 2 matrix. Okay, we don't need it, plus 0 times another 2 by 2 matrix. We don't need this this part, because 0 times anything is 0. So the value will be here 3 times 6 times 5 is 30, minus 4 times 7 is 28. So this becomes 3 times 2, the result is 6. Determinant of A is 6. The required thing is the determinant of A transpose times the determinant of A transpose times A, which is the squared value of the determinant of A. Okay, you can square it. So 6 square means 36. So the required answer is 36, which is in B. For n by n square matrix A, which one of the following is true? Let's see the choices. Determinant of A, and determinant of A is the negative of the determinant of A transpose. This is wrong. Okay, this is not true. So we ignore it. If K is a scalar, then determinant of K times A transpose is K the power of n times determinant of A. This is one of the well-known properties of determinant. Therefore, automatically our answer will be B. So let's check the rest. If B is a matrix obtained from A by interchanging 2 rows of A, then determinant of B will be the negative of determinant of A. So this is also wrong. If we interchange the rows, the determinant will be, the sign of the determinant will be changed. So the determinant of B will be the negative of the determinant of A. So C is wrong. Let us check for D. If A is invertible, then determinant of A is determinant of A inverse. This is also wrong. Determinant of a matrix A is 1 over the determinant of its inverse. Okay, so D is wrong. So automatically our answer will be B. What are the values of gamma and mu so that this system has infinitely many solutions? You can refer back question number 4. I did a certain system of equation in the form of matrix in question number 4, but you can immediately answer this thing only by observing. For example, let us compare the second and the third equation. You can simply compare the second and the third equation. So if gamma is 3, which will be exactly the second equation, whenever mu is also 3, I mean mu is 10. So when mu is 10, I mean when gamma is 3 and this mu is 10, you will have the second and the third equation which are exactly the same. So if you have two equations which are the same, the system will have infinitely many solutions. In fact, we have a certain condition, mathematical condition for unique solution, infinitely many solution, and no solution. There are conditions, but here shortly you can make like this. Therefore, this system will have infinitely many solutions whenever gamma is 3 and mu is 10. So it's very simple. You need to be very technical to answer this kind of questions. Let A be a 3 by 3 matrix, a 3 by 3 invertible matrix, and B be any 3 by 3 matrix. If the determinant of A is small letter a and the determinant of matrix B is small letter b, then which of the following is not true? So here it's all about the property of determinant of a matrix. If we see the choice in A, the determinant of A transpose times the determinant of A transpose times A, which is the determinant of A transpose times the determinant of A, both of them are equal. So determinant of A transpose and determinant of A are equal. So in place of this, you can use determinant of A. So it becomes a squared value of determinant of A, which is small letter a squared. Therefore, A is, the statement in A is true. Let's check the choice in B. The determinant of a certain constant times the matrix A is equals to K cube times the determinant of A. This works for any K an element of real number because the dimension of A is 3 by 3. Therefore, K becomes, this product becomes K cube times the determinant of A. This is true. So still the choice in B is also true. Let's check the C case. In C, we do have the determinant of A transpose times B. This is the same as the determinant of A transpose, A inverse times the determinant of B using the property of determinant. But the determinant of A inverse in terms of determinant of A can be expressed as 1 over the determinant of A times the determinant of B. Okay, but here the determinant of B is small letter b, the determinant of A is small letter a, so the whole this thing is b over a. So here it says a times b, it's not a times b, the result is b over a, so this is the wrong statement, which is the required answer. Again, let's check the statement in D. In D, if the small letter b is if the small letter b is 0, that means if the determinant of the matrix B is 0, then B is not invertible. This is a correct statement. This is a correct statement. B will have an inverse if the determinant is different from 0. Here, if the determinant of the matrix B is 0, then it will not have an inverse. That means it's not invertible. So the only wrong statement about these two matrices is the statement in C. So our answer will be C. If A is a 3 by 3 matrix and determinant of A is 5, then find the determinant of the 2 times A transpose times A. So let's calculate the determinant of 2 times A transpose times A. We can write this thing as the determinant of 2 times A transpose times the determinant of A using the property of determinant. So here you need to be very familiar with the properties of determinant. Otherwise, it's very difficult to calculate this thing. So this is the same as 2 to the power of 3 times determinant of A transpose times determinant of A. Again, determinant of A and determinant of A transpose are the same. Therefore, in place of determinant of A transpose, you can substitute determinant of A. Okay, you can substitute determinant of A. So determinant of A times determinant of A is determinant of A square, or you can use 5 in place of determinant of A because already it's given. So 2 to the power of 3 is 8. Determinant of A is already given. It's 5 times 5. This is 40. 40 times 5 is 200. Therefore, the answer for this will be A. If 2 times the inverse of the given matrix is given here, 3, 2, minus 5, 4, then what is the value of x? Here, I want to tell you about the inverse of a certain 2 by 2 matrix. Say, let a matrix A is a 2 by 2 matrix with entries A, B, C, D. Then the inverse of this matrix is given by, 1 over determinant of A times, we interchange the place of the diagonals D, A, and the rest we put by changing the sign. So this is the the inverse of the given 2 by 2 matrix. So you can also write this thing as 1 over AD minus BC into D minus B minus CA. This is the inverse of the given 2 by 2 matrix. So we will apply this concept here in the given question. So the question is 2 times the inverse of 2x, x minus 5 minus 3 is, the inverse of this one is 3, 2 minus 5 minus 4. Okay, so we want to calculate the value of x, but here we need to know the inverse of the given matrix here. So using this formula, the inverse of 2x, x minus 5 minus 3 is given by 1 over, the inverse of this one is 1 over the determinant of this matrix, which is minus 6x minus 5x into, then we change the place of the diagonals, and the rest will be as it is by changing the sign. Okay, so the inverse of the given matrix will be 1 over minus x times minus 3 minus x 5 2x, okay, multiply by 1 over minus x, the result becomes 3 over x, here it becomes 1, minus 5 over x, here it becomes minus 2. This is the inverse. So in place of this one, we will substitute this result. So here it becomes 2 times 3 over x, 1 minus 5 over x minus 2 is equals to 3, 2 minus 5 minus 4. So here multiply each entries by 2, it becomes 6 over x, here it becomes 2, then minus 10 over x, here minus 4 is equals to 3, 2 minus 5 minus 4. Now you can compare by equality of the two matrix. 6 over x must be 3. 6 over x must be 3. This means x must be 2. 6 over x is 3 means x is 2. So this is the required answer. X is equals to 2 is our answer. if A is a square matrix of order 3 and determinant of A is 5, then what is the value of the determinant of A times the adjoint of A? So let us use the information to calculate the required question. So the question is determinant of A times the adjoint of A. So in place of the adjoint of A, we need to substitute its equivalent expression. We know that A inverse is calculated by 1 over the determinant of A times the adjoint of A. This is the formula, one of the formula for finding the inverse. Here the determinant of A is already given. So A inverse is equals to 1 over the determinant of A is 5 times the adjoint of A. So multiplying both sides by 5, the adjoint of A can be expressed as 5 times A inverse. So in place of adjoint of A, we can substitute 5 times A inverse. So let us do the calculation. Determinant of A times the adjoint of A. The adjoint of A is the same as determinant of A times determinant of the adjoint of A. Okay, so in place of adjoint of A, I will substitute 5 times A inverse. So this means determinant of A times determinant of 5 times A inverse. Okay, so this is the same as determinant of A times 5 to the power of 3 times determinant of A inverse, but determinant of A inverse is 1 over determinant of A. So determinant of A times 5 cubed times 1 over determinant of A. From the property of determinants, determinant of A inverse is the same as 1 over determinant of A. So now this can be cancelled out. The remaining thing is 5 to the power of 3. 5 to the power of 3 is 125. Therefore the required answer is C.